Hello, everybody. Okay, so I just learned. Well, I didn't just learn this. I knew this for a while, but I just put it into practice. Okay, all in computer graphics, whenever you want to define a 3D object, what they do is have the points, but the face is made up of triangles, completely made out of triangles. If you want to say make a 3D model of this will be approximated using nothing but triangles. Why do they use triangles? Because triangles, no matter where you put the points, it will always stay a triangle. Can't use rectangles because if you move one of the points, it will no longer be a rectangle. It'll be like a kite or something, some other polygon, or even a trapezoid, or a square. You can't use squares. And also with triangles, there's only one configuration, right? Each one connected to every other one. But with a square, there's a few different configurations, and the more points you use, the more configurations you can have. So a square could be square, but it can also be like this, using the same exact points, and that gets kind of goofy when you're doing 3D graphics. But they use triangles. That's why they use triangles. So what I wanted to do in my next step in making this 3D engine, I wanted to go ahead and be able to define 3 points, make lines between all of them, and also having an inequality or some sort of phrase or something that can tell whether or not you're inside the triangle or not. Because then I can use it to define any other shape I want. I could do a rectangle, 2 triangles, right there, and just combine them together. If you touch either of those, you're inside the square. I can even do something weird as this. Fill this entire surface with triangles to represent it, and say if it touches any of those triangles, you are inside of this object. Because it will be extremely hard to define other points and do the mathematical equation, because I bet there's one, to define where these points are. So you use triangles instead. That's why when you look at the wireframe of 3D objects, they always form triangles. They always do. Yeah, so I went ahead and made it. I first had to go ahead and simulate before I start programming. So I went ahead and made it in Desmos. Desmos right here. These are the equations I used. These are the lines. These are the constraints. This is the actual equation for the 3 lines. And then this defines the area of it inside, right? So no matter where I move these points, it will always define these things. Absolutely amazing. Okay, so I went ahead and made the code, and it works like a charm. Okay, let me just. This is the 3D engine thing I made. Has a cube rotating, and one thing. Oh. Okay, look, 3D cube moving. 3D cube. Oh my. It's because okay, 3D cube, you can change the perspective, and now it has little dots. It's because the wires are loose. That's why. It's not because the computer's broken or anything. It's because the wires are loose. But yeah. This is a 3D cube orthographic, and I can change the perspective. Change the perspective like this, and now it looks like it's popping out. Get that real 3D feel to it. You can see that. Looking amazing. Come on. There we go. See that? Yeah, get that 3D. Okay, but that's not what I want to show you. I want to show you this. I'm going to go ahead and generate a triangle and also a bunch of dots to show that I can actually find the collisions of these things. Now, it's going to look like a filled triangle. That's basically what I wanted to do, was make a filled triangle, filled triangle, and the library I'm actually using to display all this, just basic lines and dots and everything, has a function to make a filled triangle. But I didn't want to use that, not because I wanted to challenge myself, because I couldn't. I could not use this because it doesn't tell you whether or not you have crossed inside. It just draws it, and then it just leaves it at that. I need to create my own so that I can use the data I gathered to actually tell whether or not something has entered inside that triangle. So here we go. Okay, let me make the triangle a bit bigger for you so you can see. Okay, so it's loading. You see all the lights flashing. So I'm gonna make the triangle bigger so you can actually see it. And the dots, if you look really closely at the dots, when they actually intersect with the triangle, they turn black. They turn black. There we go, this is a good triangle. If you look very, very closely, come on. Can you guys see it? It won't focus. Come on, buddy, just focus. Come on, buddy, focus, man, so the tube can see. Yo, guys, this is really tough, man. You can't see, but you gotta believe me, man. It does exactly what I said. It does exactly what I claim it does. And in the next video, I'll make it a much better demonstration. And also, I will make it so that it doesn't just work with triangles, because you can combine these triangles to make any other shape you want. Like the dollar I showed you, I want to go ahead and make another function or whatever to make a shape of defined points and turn it into just a collusion of triangles, and then use those triangle boundaries so that I can make the boundary boxes of any shape I could possibly want. That's the next step. That's the next goal of what I want to do. So yeah, then after that, I want to go ahead and make a 3D triangle. Because I already have the perspective and all that stuff done. I can make a 3D triangle and see if I can collide it with that. And then once I make that, get a 3D object, define it using 3D triangles, and collide it. Meaning, I have a 3D collision system in my 3D engine. That's the next step, though. I haven't got that far yet, but see ya.